The topic we're going to look at today and in other future episodes are related to both the origin and ultimate fate of our existence. This might sound strange, but we're going to look at nothing today. I know, this is what happens every time the concept of nothing is being discussed, the vocabulary confusion. For example, if I start to ask the simplest question appropriate for this episode, what is nothing? The question would contradict itself, because the question implies that I'm trying to describe something, but nothing is not something, it's the absence of something. The vocabulary issue when contemplating an idea like this is nothing compared to so many other cognitive challenges one might have when dealing with this strange concept. It's amazing how discussing about nothingness could lead us to very interesting and fundamental concepts. The more you dig into this topic, the more interesting it gets. During our discussion, I'm going to mention some scientific words like quantum fluctuations, the uncertainty principle, or cosmological cycling models, which I'm going to cover in future episodes. Explaining all of these topics in a single episode would be confusing. I'm going to introduce some very basic ideas about nothingness, just to get us warmed up. When we fall into a deep sleep without dreaming, we can say that we are diving into unconsciousness, or nothingness. One can argue that there's no dreamless sleep. Even if that's true, when we wake up and can't remember any of our dreams experiences while we were asleep, we can't think of anything, which implies, well, nothing. When you want to remember the time before you were born, what do you think of? That could be also nothing. According to cosmologists, the universe is expanding. But what is it expanding into? Although this is a naive question, which I'll cover later why, it's an obvious question that comes to mind, and the simple answer would be nothing. As some theoretical physicists suggest, our universe is not the only universe out there. There's a huge number of, or maybe an infinite number of universes in a multiverse structure, and the space between those universes could be naively imagined as nothing. While you were thinking about the ideas just discussed, were you really thinking about nothing? That must be no, because well, you can't think of nothing. We just can't. You might also think of empty space as nothing. Is empty space a good candidate for nothingness? That's a big no. Empty space is something with many properties. When we want to focus on taking everything out of our thoughts, we always end up with something in our minds. Let's say total blackness. The total blackness is still something, isn't it? The absence of something shouldn't have color. Even if the entire universe decays into nothingness, we can arguably say that nothingness is something, because the universe decayed into it. Scientists have built the LHC, the Large Hadron Collider, the largest particle accelerator ever made to simulate the high energy state of the Big Bang, with the purpose of understanding the initial conditions of the very early universe right after time equals 0. That seems reasonable, but it's logically impossible for someone to design an experiment to demonstrate non-existence giving rise to something, because we're contained by something. And that something is our universe. Our universe lacks nothingness. So is there any evidence for nothing? Can we even imagine a piece of evidence for nothing? It seems highly unlikely. Let's stick to what we do know for now. No matter how hard we look, we're never going to experience the complete and total absence of something in our universe. What was thought to be empty space, or void, or vacuum is actually not empty. To tackle the concept of nothingness, we shouldn't get lost in some abstract ideas. Instead, we should stay inside of scientific boundaries to constantly stay in touch with solid and well-established facts. Since we want to talk about the fundamental ideas in the realm of science, we should look into the theory of quantum mechanics, a branch of physics dealing with reality at its most fundamental level. First, let's define nothingness in the realm of quantum physics. In quantum theory, nothing is described as fundamental energy fields, or quantum fields, which is available everywhere, having an unimaginably small size and non-zero value, always fluctuating without rest. Those fluctuations are called quantum fluctuations. According to our current understanding of quantum mechanics, more specifically the uncertainty principle of quantum mechanics, anything with a non-zero probability should and will pop into existence out of excitations of quantum fields, no matter how extremely improbable it is. Anything that doesn't violate the laws of quantum mechanics will eventually find its way into existence. In fact, anything that can happen must eventually happen, possibly for an infinite number of times. So the fact that instead of nothingness, there's a universe containing human intelligence asking remarkable questions shouldn't be surprising at all, because its creation, according to uncertainty principle, had a non-zero probability. It seems like there's no definite reason why our universe is the way it is. Our universe is one of many uncountable possible states that the universe could have. Anything that is allowed to arise from potentiality and become reality will eventually do so. As the theoretical physicist Alexander Vilenkin states in his paper, The Principle of Mediocrity, you can ask, what caused the universe to pop out of nothing? Surprisingly, no cause is needed. If you have a radioactive atom, it will decay, and quantum mechanics gives the decay probability in any given interval of time. But if you ask why the atom decayed at this particular moment and not the other, the answer is that there is no cause. The process is completely random. Similarly, no cause is needed for quantum creation of the universe. There are many other respected theoretical physicists, such as Stephen Hawking, Alan Guth, and André Linde, who have formulated theories or offered explanations on how a universe could come into existence from random quantum fluctuations. Energy fields occupying the entire existence are endless seas of potentiality, giving rise to every possible state of existence that agrees with the laws of quantum mechanics for an infinite number of times. You can think of these fields as random universe generators, each universe having its own laws of physics. Let's go over some examples. Example 1. Assume you have a software program in your computer. That software is stored in your computer's storage device. As soon as you execute the software, your computer goes through a series of processes to load the software for you to interact with. So the potential of that information led to the software execution. Example 2. You have some thoughts in your mind about doing something, and that's your potentiality to do the thing you're thinking about. The idea of doing something is going to be actualized at the moment you take action and act upon your thought. Before your action, your thought is just an idea, the potential of your action. Example 3. Consider a hologram. You can generate a 3D holographic image by shining a laser beam on its plane. Before the 3D holographic image is created, the information of that 3D hologram was stored in its plane surface. After shining a laser on it, you have activated its potentiality and caused the 3D holographic image to manifest itself. Example 4. The Library of Babel, an online library of 10 to the power of 5,000 pages, which contains everything already been written and that will be written. Look for every possible 3200 character combination of English letters in this library, and it will come up as a search result in some pre-existing page in one of its books. Every idea, every name, every question, including its answer. A theory of everything that explains everything in our universe is already in this library, waiting to be looked up. The software program stored in the storage device, your thoughts, information stored on hologram's surface, and the Library of Babel are all different potentials, just like the energy fields we have mentioned before. The executed software program, your action based upon an idea in your mind, 3D holographic image, and the search result in Library of Babel's website are actualizations of those potentialities. The online library example is the most suitable one, because every possible outcome already exists in it, just like the energy fields with the potential of creating every possible universe. We can imagine a model of creation in which there is no such thing as a first mover that caused something to exist, followed by a chain of creations and destructions towards the future infinity. Instead, we can think of a cyclic model of infinite beginnings and ends without a start or an ultimate ending. There are so many cosmological cyclic models, each having its own eternal cycle of universes. After being created, each universe reaches its end and leads to the birth of another universe. And this process might go for infinity, both into the past and future. We will cover these cyclic models in future episodes. By considering a system of infinite regression of formation, evolution, and death of universes, there's no need to think that at some point in the far past there was nothing. Scientists such as Sir Roger Penrose, Neil Turok, Paul Steinhardt, and Lisa Moline have formulated different cosmological cyclic models. Each model will be covered in detail in its own episode. By asking the question, what caused the Big Bang, we are implying that there was a history before the Big Bang, which brought our universe into existence through some mechanism. The universe can't be its own explanation, so there should be something that caused the universe to come into existence in the first place. An infinite cycle of creation in the past is not impossible or inconceivable. If a universe can potentially come into existence, the quantum mechanics suggest that it could have come into existence in the past and will be in the future. There is no accepted modern scientific theory introducing nothingness as the prior state of existence. According to our current understanding, energy is something that has always existed without a cause, leaving no room for nothingness. Nothingness is probably just a product of the human mind. Since we understand the existence of something, we also can think of the absence of that something to some degree, and then start to wonder if such a state has ever existed. Our Darwinian brains usually tend to assume nothingness as the default state. Our universe has fundamental and unbreakable laws, which leads to basic principles and universal facts. Nothingness has no laws, and thus no facts. Therefore, the creation of something out of nothingness, containing no principles, no laws, and no facts, is impossible. In the realm of quantum mechanics, instead of dealing with something arising from nothingness, we are dealing with what came into being, in some quantity, and the probability of such a thing to find its way into existence. If we want to study the existence, we shouldn't ask why, but how the universe came into being. That's a reasonable question that, if studied well, can uncover many secrets about our universe and reality as a whole. So if something always existed, and assuming that universes are being created every once in a while, we can conclude that not only the fundamental and eternal layers of reality have always existed, but also there have been an infinite number of histories before ours, and so in the future as well. An infinite cycle of existence is something incomprehensible for us. But that just demonstrates our limited mental capabilities. Just because we can't comprehend something, it doesn't mean we should rely on abstract ideas without any base on reality. What this means is that we should do more science and research, come up with ideas, design experiments to test hypotheses, construct scientific theories, and achieve a comprehensive theory of everything that describes the majority of the phenomena we experience. It makes sense to consider something as the default state, not nothingness. At least, that's what current-day science tells us. Quantum mechanics implies that a world with absolute absence of something simply is not an option. Even if nothingness really exists, we wouldn't know about it anyways. Because after all, how can we possibly be aware of something that isn't there? If that even makes sense. The concept of something coming out of nothing is so unknown to our intellect that we can't even begin to think of a thought experiment for it. When contemplating nothingness, one can't help but ask the famous question, why is there something rather than nothing? A question that either is one of the most magnificent questions ever raised by humanity, or it's one of the most misguided, misleading, and irrelevant questions that has ever been asked. So why is there something rather than nothing? Well, as quantum mechanics suggests, there has to be. Because in a reality governed by the laws of quantum mechanics, we'll always end up getting something. Then we might want to ask, where did the laws of quantum mechanics come from? Are those laws eternal? That looks like a very tough question to answer, if there even is an answer in the first place. Another sensible approach to the question, why is there something rather than nothing, is to change the question into why must there be nothing and not something? Changing the question will not provide us with the answer, but that's the key point. When a question is based upon confusion and misunderstanding, then we need to adjust the question. One simple idea suggests that there could be an infinite number of combinations of something, but only one for nothingness. So probabilistically, it's highly likely to be something rather than nothing. I'm going to end this episode with a 3-word quote, which will be your topic of discussion for the next episode, from the Nobel Prize winner scientist Frank Wilczek. Nothing is unstable. Thanks for watching. Don't forget to share and subscribe if you haven't yet, and stay curious.